So what if I told you that the difference between really chaotic, tangled thinking and just pure, elegant logic could come down to literally a single keystroke?
I mean, it's a pretty fascinating premise, right?
Yeah.
Because we usually think of punctuation as, well, something confined to just literature or grammar.
Yeah, like saving a sentence from being ambiguous or something.
Exactly. But when you move into the realm of computer science,
Mm.
punctuation actually becomes architectural.
Hmm.
Like it dictates the physical structure of a thought.
And the specific architecture we're diving into today comes from this really, really detailed blog post. So our source material for this deep dive is titled Elegant Composition, Balancing Logic and Data in Haskell.
Right.
And it's actually part 131 of a long-running series called Notes on Haskell Programming by an author named Eng. And this was just published today, May 9th, 2026.
Which, I have to say, reaching part 131 of literally any technical series requires a level of dedication that is just, it's frankly incredible.
Totally. It's a massive undertaking.
Yeah, Aang is clearly someone who spends a lot of time thinking about not just, how to make a program function, but how to make it beautiful.
Right.
And Haskell, for those who might not be super familiar with it, it's a purely functional programming language. It's really heavily rooted in mathematics. So the people who use it tend to completely obsess over the elegance and the purity of their code.
Okay, I want to jump in right here and just offer a quick promise to you listening. The phrase purely functional programming language just made your eyes glaze over. Please do not tune out,
Yeah, stick with us.
because you really do not need to be a coder or a math genius to get what we're talking about today. We're just using this one specific language, Haskell, as a sort of lens to look at a deeply universal human problem.
That is definitely the best way to approach this, because the core tension in Aang's post isn't really about software engineering at all.
No, not really.
It's about how we organize complex systems,
Hmm.
like how our brains actually handle cognitive load when we're trying to read a complicated set of instructions.
Exactly. So this is essentially a journey into finding the perfect structural sweet spot. We're going to explore a literal battle between two tiny symbols on your keyboard.
The dot and the dollar sign.
Yes, the dot and the dollar sign. And to really appreciate why Aang is searching for this elegant solution, we first have to, experience the sheer messiness of the problem.
Right, because every good evolution basically starts with a frustration. So Aang begins the post by showing us this single line of code that represents a really common everyday task in programming.
Right. But before we get into the actual punctuation of it, let's look at what this code is practically trying to accomplish, like conceptually.
Good call. So the program has a piece of raw data, and in this specific case, it's just a simple text string that says unsupported format.
Okay, unsupported format. Got it.
And the system needs to take that raw text, prepare it to be read, flag it as a specific type of error, and then finally wrap it up in a protective layer so the rest of the application doesn't just completely crash when it sees it.
So it's essentially like a four-step assembly line. You have to pack the text up, then label it as I think it's called a pandoc error, right?
Yeah, Pando-Capper, exactly.
Okay, and then you tag it as something called left, which usually means an error state in this context, and finally make it pure, which packages it up safely for the broader system to actually handle.
So that is the exact sequence, yeah.
Yeah.
But the problem isn't what the code does, right? The problem is how it's actually written out.
The syntax.
Right. Aang shows us the original way someone might write this, and it is just a structural nightmare. The raw data, that text, unsupported format, is literally buried inside 4 layers of commands, and they're all trapped inside these nested parentheses.
Yeah, it looks awful. Like for you listening, imagine a set of those wooden Russian nesting dolls. You have this massive doll on the very outside.
Your command.
Right, the pure command. And to get to the actual core data you care about, the text string, you have to physically open that outermost doll, and inside that, you find the left doll.
And you open that one.
Exactly. You open that to find the Pando-Capper doll, you open that to find the pack doll, and finally, inside that fourth doll, you uncover the tiny wooden peg in the center that holds the actual text.
I love that analogy because it perfectly captures the cognitive burden of reading this type of syntax.
Mm.
From a purely psychological standpoint, reading heavily nested parentheses forces the human brain to read from the outside in.
Which is so unnatural.
It really is. And
Uh-huh.
you have to simultaneously hold all of those pending operations in your short-term memory.
Right, you have to remember, okay, I'm in the pure state, but I'm waiting on the left state, waiting on the error state, just to figure out what the error actually even is at the center of it all.
Exactly. It's a massive tax on your working memory. Like, the computer has zero problem parsing it, obviously.
Mhm.
But for the human programmer who has to read and maintain this code, it's just exhausting.
They actually call it parentheses hell, don't they?
They do, yeah. So Ang takes a first logical step to try and flatten this structure out and basically escape the nesting dolls.
Okay, so let's talk about that first escape attempt. Ang swaps out all those nested parentheses for a totally different piece of syntax, which is the $sign.
Right. So in Haskell, the $sign operates as what's called the function application operator.
Okay, what does that actually mean in plain English?
Basically, when you place a $sign between two things, it tells the compiler, hey, stop right here. I want you to completely evaluate everything on the right side of this symbol before you feed it back to the left side.
Oh, interesting. So instead of wrapping each command in its own set of curved parentheses, Ang just separates the commands with $signs?
Yeah, sure.
You have the pure command, then a $sign, the left command, a $sign, and so on, until you finally reach the data at the very end.
Exactly. It flattens the Russian nesting dolls into this single horizontal line. You just read it from left to right.
Right.
And the $signs act like little dams holding the functions apart until the data is finally ready to flow through them.
Okay, but wait. Let's unpack this for a second, because Ang refers to this specific approach as feeling like alphabet soup.
Yeah, that's the exact phrase used.
And I totally get why. Because while it technically flattens the structure, looking at a long chain of $signs honestly feels kind of just as messy and repetitive as the parentheses did.
It really does.
We basically just traded curved lines for spiky ones. It feels like an aesthetic swap, not a genuine structural improvement, you know?
You're picking up on the exact frustration that drives Ang to the next step.
Yeah.
Because you haven't fundamentally changed the relationship between the functions. You've just, used a different character on the keyboard to separate them.
Right.
Plus, as Ang points out in the post, you still end up needing a set of parentheses at the very end anyway, just to bundle the final pack command with the unsupported format text string.
Oh, right. So the $sign approach is basically just a Band-Aid. It doesn't cure the underlying disease of the cluttered syntax.
Exactly. It's a totally messy compromise, which naturally leads us to the next phase of this whole evolution. Because if the $sign creates an alphabet soup, the logical extreme is to just swing the pendulum in the completely opposite direction.
Right. Throw the $signs in the trash.
Basically, yeah.
Yeah.
Get rid of the $signs entirely and try to rewrite this sequence using only the dot operator.
And this is where things get really cool, because this is where the deeper philosophy of Haskell begins to shine. The dot, which just looks like a standard period, has a really profound meaning in this language, right?
It does. It's known as the function composition operator.
Composition, that sounds like we're building something entirely new rather than just lining things up in a row like the $signs did.
That is precisely what it does. Instead of telling the computer, take this data, apply this function, then take the result and apply the next function, the dot operator allows you to actually glue the functions themselves together.
Wow, okay.
Yeah. You're taking 4 separate machines and essentially welding them into one single massive mega machine before the data even enters the room.
So Ang writes out the code again, but this time the pure, left, pando, capper, and pack functions are all just joined by simple dots. They're structurally fused together.
Yes. And Ang uses 2 vital pieces of programming terminology to describe what's happening here: point freestyle and partial application. And we should probably break those down so the conceptual leap actually makes sense.
Yeah, let's do that, because pro freestyle sounds incredibly minimalist. It almost sounds like a mid-century modern design trend or something, where you hide all your appliances behind flat wooden panels.
That's actually a great way to picture it. It carries a very similar minimalist ethos.
Yeah.
But Ang explicitly warns the reader not to be confused by the name. In this mathematical context, the point doesn't refer to the dot operator itself.
Okay, so what is the point?
The point refers to the raw data, the final argument that the functions are actually going to act upon.
Ah, I see. So point free simply means we're writing out this whole chain of logic without explicitly mentioning the data yet. It's purely just instruction.
Exactly. And that leads directly into partial application. By chaining all these functions together with dots, we've built the entire processing pipeline, but we haven't actually applied it to anything yet.
It's just sitting there.
Right, we've partially applied the logic. The pipeline is fully constructed, sitting there, completely empty, just waiting for the text string to be dropped in.
Okay, conceptually, this sounds beautiful. We've completely separated the pipeline from the water that flows through it. But this brings us to what I think is an absolutely incredible irony in Eng's post.
Oh, it's so good.
You really have to appreciate the dark humor of this, especially if you've ever tried to optimize a system in your own life and somehow ended up making it way worse.
The classic trap of over-optimization.
Yes. Because the entire goal of this exercise, going all the way back to the very start, was to get rid of the parentheses. We hated the Russian nesting dolls. We wanted clean, flat, elegant code. But look at what happens when you use this purely point-free style.
Well, the compiler still needs to know where the logic ends and the data begins.
Right. Because you just glued 4 functions together into a mega function, the system gets totally confused if you just leave the raw data sitting right next to it with no barrier.
Exactly.
So to make the code actually run, this clean, minimalist, point-free style forces you to wrap the entire block of logic inside a giant set of parentheses, just to wall it off from the data at the end.
It is a brilliant paradox. You successfully eliminated the little nested dolls, but to satisfy the rules of the syntax, you had to build a giant curved fence around the entire factory anyway.
You ran in a massive circle.
You did. By trying to be purely mathematical and completely point-free, the syntax demanded the return of the exact same parentheses you were trying so hard to escape.
It's infuriating. The pendulum just swung way too far. So, okay, if all dollar signs is just an alphabet soup of spiky barriers, and all dots creates this circular paradox where we accidentally reinvent parentheses, we're left searching for the actual correct answer. What is the sweet spot?
This is the climax of Eng's whole exploration. And it leads us directly to what is considered the elegant middle ground, the true idiomatic standard in Haskell.
Okay, lay it on me.
The solution isn't to choose one symbol over the other. The solution is to use both, but for entirely different conceptual reasons.
The grand reveal. What does this final preferred idiom actually look like structurally?
It's a synthesis of the two approaches. Eng writes the first 3 functions, pure, left, and panda capper, and glues them together using the dot. So we have our composed point-free logic pipeline.
Okay.
But then right at the very end of the logic, right before the final pack function and the raw text data, Eng places a single $sign.
So there are no parentheses anywhere, just dots gluing the first 3 steps and $sign acting as a gateway before the final step and the data.
That is the structure. And the reason this is considered the idiomatic, elegant way to write Haskell isn't just about saving keystrokes or making the screen look less cluttered. It's about establishing a hard semantic boundary that the human eye can instantly recognize.
A boundary between the machine and the material.
Precisely. When a programmer reads this line, the dot operators communicate a really specific concept. I am building a process. The dots are read as a cohesive block of logic.
Right.
But when the eye hits that single $sign, it acts as a visual signpost. It tells the brain, the logic is ended, the factory is fully built. Everything past this point is the raw material that we are feeding into the factory.
I want to really expand on this visualization because I think it's such a powerful mental model for anyone. Imagine a massive, really complex factory assembly line. You have all these different mechanical arms, stamping presses, conveyor belts.
The functions of our program.
Right. And the dots, the function composition operators, are the heavy steel bolts physically snapping the different pieces of machinery together. So the pure machine is bolted tightly to the left machine, which is bolted to the pando capper machine.
And it becomes one continuous, unified, immovable piece of logic.
Exactly. It's a single entity, the heavy machinery. But the bolts just hold the metal together, right? The machine can't actually do anything on its own. It needs material. So at the very end of this massive bolted together contraption, there is a giant metal funnel. And that funnel is the $sign.
The function application operator.
Yes. The $sign is the funnel where you finally pour in the raw materials. You pour the text string unsupported format right into the funnel and the machine turns on. It completely separates the process from the problem. You've got logic on the left side of the funnel and data on the right side.
That analogy perfectly captures the exact cognitive shift Eng is highlighting here. When you look at the nested parentheses, your brain has to untangle the machine while simultaneously holding the raw material in your head. It's a mess.
It is.
But when you use this elegant composition, you can visually parse the entire sequence in a fraction of a second. The dots build the machine. The $sign feeds the machine.
It's deeply satisfying because it maps to how we actually want to solve problems. We want to build a tool and then use the tool. We don't want to be building the tool while we are actively trying to use it.
No, that's impossible. And that desire for clear, separated structures isn't just a programming preference either. It's rooted in a much older, deeper discipline. Aang doesn't just leave us with a clean line of code. The post actually zooms out to show how this elegant programming solution is a direct reflection of pure mathematics.
Yes. Aang translates this final line of code into a formal mathematical expression to really prove the point. And instead of reading a super confusing string of variables out loud, let's just talk about how the math visually groups these concepts together.
Sure. So in formal mathematics, function composition is represented by a tiny hollow circle. So Aang writes out the logic block, the pure, the left, and the error function, and groups them together inside one set of brackets, separated by those tiny composition circles.
So the math literally creates a designated machine block on the left side of the equation.
Exactly. And inside that machine block, Aang makes a specific technical note about the pure function, identifying it as the unit function in monads.
Okay, pause. Monads are infamous in computer science for being incredibly difficult to explain, but we really don't need a PhD to understand its role here, do we?
No, not at all.
Think of a monad simply as a special, highly secure shipping container. The unit function's job is just to take a piece of data and place it into the secure container so that the rest of the system knows exactly how to handle it, especially if that data is carrying an error message.
Right, it provides a safe context for the data to travel through the system. So we have our fully composed machine block on the left, complete with its monad shipping container. And then on the right side of the mathematical equation, grouped in its own entirely separate brackets, is the raw data, the x variable representing our text string.
So the machine block acts upon the data block. The code perfectly mirrors the fundamental laws of mathematical logic.
And this is exactly where Aang leaves us with a truly profound concluding thought. The post asks us to just consider how fascinating it is that such a microscopic syntactic shift completely changes our reading and our entire mindset.
Because the actual instructions the computer received never really changed, did they? The computer was always going to pack the text, label the error, and wrap it up.
Never changed. The machine doesn't care about elegance. The machine just calculates. The punctuation exists entirely for the human mind. Yeah. We transitioned from a claustrophobic, tangled mess of nested instructions that demanded massive cognitive load to an intuitive, beautifully separated expression of pure logic acting upon pure data. And we did all of it just by strategically deploying a dot and a dollar sign.
It really is a masterclass in the architecture of thought. We journeyed from the frustrating Russian nesting dolls through the chaotic alphabet soup of spiky dollar signs, right into the trap of the point-free paradox where we accidentally reinvented the fences we were trying to tear down.
Yep.
All to finally arrive at this elegant, necessary boundary between the machine and the material.
It highlights a universal truth about any complex system. Clarity doesn't come from getting rid of all the boundaries. Clarity comes from placing the boundaries in the exact right spot.
Which brings us to the ultimate question for you listening. Why does a highly technical blog post about Haskell programming from the year 2026 matter to you right now, especially if you have absolutely no intention of ever writing a single line of code?
It matters because the core problem Aang is solving isn't limited to software. The tools and the structures we use to represent our ideas fundamentally limit or expand how effectively we can work with those ideas.
Think about how this applies to your own cognitive load every single day. This deep dive proves that mixing up the process with the problem creates a massive mental traffic jam. When you try to design a system while simultaneously processing the raw data that goes into it, you end up with the real-life equivalent of nested parentheses.
You lose sight of the logic entirely because you're just too bogged down by the data.
Exactly. So I want to leave you with a lingering thought to explore today. Think about the hidden syntax of your own life. Think about the daily systems you rely on, the way you format your project planning, how you structure your digital calendar, or even just how you mentally organize your morning to-do list. How often do you let the messy, raw data of your day, the specific emails, the sudden crises, the urgent text messages get completely tangled up in the logic of your routines?
Are you building the assembly line while trying to process the raw materials?
Or are you finding your own elegant composition? Are you setting a hard semantic boundary, your own personal dollar sign that clearly separates your logical processes from the chaotic data of your life? It's a tiny shift in structure, but as we've seen today, that tiny shift can fundamentally rewire how you process your reality. Until next time, keep diving deep.